Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 30th of April. It is a Thursday, and it is a day 1 in our rotation. So it's our last day of April. We're almost on to the second to last month of school, our last full month of school, which is crazy. So I hope you're all doing well. Hope you're all keeping up with the work at school at home. Hope you're staying safe and positive and still working hard in these crazy times. So today we're continuing to work with the lesson on molecular shape. What I'm going to do is I'm actually going to go over a couple example problems from the Smells Lesson 11 review. So a couple of those problems towards the end that are a little bit more difficult, that have you drawing Lewis structures and identifying the electron domains and shapes and all that kind of stuff. We're going to go over those so you have real examples of how to do these problems and how to work through them, okay? So right now, the first thing I'm going to do is go to number 7 in my Smells Lesson 10 review. So if you're working through this today and you need some help, this is going to help you work through this, right? Okay, so number 7, first of all, says use the periodic table to help you with questions 7 through 10, which is great. And it says to draw the Lewis structure of CF4. How many bonded pairs would be around the central atom? Okay, so in order to do this, we have to start with our molecule, CF4. When we draw a Lewis structure, am I really dark today? Turn my brightness up. Yeah, my brightness is really low. Sorry about that. So to draw the Lewis structure for CF4, the first step that we need to do is figure out the total number of what? We need to figure out the valence electrons, right? Okay, so if we look at our periodic table CF4, C is in column 14 or column 4A, so it has 4 valence electrons. So I'm going to write that. And F is in column 17 or 7A, so it has 7 valence electrons, right? But that's times 4 since there are 4 F atoms. So 4 plus 7 times 4, that's 28. That would make this 32. Okay, so there'd be 32 valence electrons in total. It's a lot of electrons. But don't worry, we should be able to fill this out pretty easily and make it work. Okay, so now we have CF4. We need to determine which atom is the central atom, which is in the middle, right? It's probably always going to be the one that there's only one of, and the one that there's 4 of is going to go along the outside. So that means C will be our central atom, and then F, and F will be our terminal atoms on the outside, right? I'm going to just erase this so we have a little bit more room. Okay, so I have my C in the middle and my F's on the outside. Now I want to start using my 32 electrons to connect each F to the C with what we call a bonded pair, right? So I'm going to put 2 electrons, or a pair of electrons, in between each C and each F. Okay, that's going to bond each fluorine to the carbon. And that takes 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. That means that carbon's happy, but it also means that we used 8 electrons, and now we have 24 left, right? Okay, so the carbon is happy. Now we need to make sure that each fluorine is happy and has an octet or 8 electrons around it, right? So let's start with this fluorine. It needs 6 more, so I'm going to add 3 pairs. Good, now it has 8. I'm going to add 3 pairs to this fluorine. 3 pairs to this fluorine. And 3 pairs to this fluorine. Okay. 2 things here. 1, I should notice that now I have 8 electrons around each fluorine. And 2, I need to check that I added the right number of electrons. I didn't add too many or too little, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I just added 24 electrons. Did I have 24 electrons to add? Yes. Exactly that many. So now I have a big 0 left. Okay. Each fluorine is happy, each carbon is happy. So this structure is good to go. Now if I look back to my original question, it says how many bonded pairs will be around the central atom, right? So if I look at the central atom, which is carbon, how many bonded pairs are there? How many pairs of electrons are there between a C and an F? And if you have double bonds, those count as 2 bonded pairs. Only one, what we call electron domain, but 2 bonded pairs. 1, 2, 3, 4. 4 bonded pairs, right? So for that answer, you should have 4 bonded pairs. There are 8 electrons. That's a tricky answer, but there are only 4 bonded pairs. Okay, Now, let's look at a second example. Let's move on to question 8, right? So question 8 says to draw the Lewis structure of H2Se. Okay, so for H2Se, we again start with H2 and Se. Se is not an element I'm super familiar with, but I'm sure I can find and figure out how many valence electrons it has. Hydrogen, we know, has 1 valence electron times 2, because there are 2 of them. And Se, if we look at Se, look at a periodic table that's up there, conveniently posted the assignment, Se is below oxygen and sulfur, which are in column 16, or 6A, and so they're going to have 6 valence electrons each. So 1 times 2 is 2, plus 6 equals 8. So just 8 total valence electrons, which makes sense because hydrogen only want 2 each. All right, which is going to be the central atom? H, there's 2 of, or Se, there's just 1 of. Se. This molecule is actually a lot like water. So it's going to have Se in the middle and 2 H's on the side. Okay. So I'm going to start by putting pairs of electrons in between H's and Se's. Okay. Now, this H only needs 2 electrons each, so it's good to go. This H only needs 2 electrons each, it's good to go. What still needs more electrons? Se. Okay. So I've used 4. I used 1, 2, 3, 4, so it went from 8 to 4. Okay. And now I have to put all 4 of these on the Se to make it have 8. And that's okay, I can add those 4 electrons because, again, I had 4 electrons to give. So now I have 0 electrons, and Se is good, and H is good. All right, so this question asks, how many lone pairs do we have? Let's figure out how many bonded pairs we have first, and then we'll circle the lone pairs in green. So bonded pairs, how many bonded pairs do we have here? How many bonded pairs do we have? We have 2, right? So there are 2 pairs between H and Se. Okay. How many lone pairs do we have? How many pairs are by themselves, not connected to any atoms? 1, 2. Right? So 2 lone pairs in total for this. So number 8 is going to be 2 lone pairs. So this is great, but we've kind of done this. We've kind of practiced this. The new thing that we're looking at today with molecular shape, and there are a couple questions about this. In fact, number 9 asks you about this a little bit, and so does 10 asks you about electron domains. The real question is, what is the shape of these molecules, right? What do these actually look like in 3D space? What is their actual shape? So if we look at CF4, our big question to start is, 1, how many electron domains are there? And then 2, what shape would that form based on that? So how many electron domains do you count around C? How many sides are there electrons on? 1, 2, 3, 4, right? There are electrons on all 4 sides. So that means there are 4 electron domains. There are 4 areas or houses, homes where you can find electrons, right? Okay. So if there are 4 electrons and there are 4 bonded pairs, that means that there are 4 atoms connected that we can actually see. Those bonded pairs connect to atoms that we can actually see. So if we look at this molecule, there you go. If we look at this molecule, it's going to have 1 atom in the center, and it's going to have 4 atoms connected that we can actually see. So what shape does this form? Kind of got a triangle on the bottom and that 1 sticking up, or if you look at it this way, it's got a triangle in the front and then 1 atom kind of just hanging out in the back, right? So that shape is called tetrahedral. Now, word tetrahedral sounds a lot like Tetris, because Tetris literally means 4 blocks, right? So tetrahedral is kind of a weird 4-atom shape, right? When you have 4 atoms connected to it. Okay, if we look at H2Se, first we count the number of electron domains, right? So how many electron domains do we have? How many sides do we have electrons on for Se? 1, 2, 3, 4. Okay, I still have 4 electron domains. There are electrons on 4 sides. But the real question now is, how many bonded pairs do I have versus lone pairs? So I have 1, 2 bonded pairs, so I can see 2 atoms actually connected to this Se. And then I have 1, 2 lone pairs. And these lone pairs, remember, I can't actually see. You can't really see electrons. You can see the outline of an atom, but you can't really see where just electrons are hanging out, right, by themselves. So in this, you will only see 2 atoms connected to the central atom. Okay? So the shape is going to be the same. The overall shape of this atom in the middle is going to be the same. Electrons are going to be pushing each other away, but you don't see these two lone pairs on top, right? These are representing lone pairs of electrons, so you don't see these two lone pairs. You only see two atoms connected. So what kind of shape is this? If you just look at it, it looks like somebody took a line and did what? They bent it, right? So this is a bent shape for H2Se. Like I said before, this molecule H2Se is very much like water, like H2O. So it has a bent shape, and that's going to be really important for us, seeing that it's bent and not just a straight line. That's going to be really important for us. Okay, so keep working with these questions. Keep working on molecular shapes, electron domains, trying to figure out what kind of shape my molecules are going to take on if they have a certain number of lone pairs, a certain number of bonded pairs and whatnot. So keep working on that. Work hard on that assignment today. Remember that I have office hours again between 1:30 and 2:30, so hope to see you there if you need some help. Don't have office hours today from 1:30 to 2:30 because I have a meeting then, but I will be on a little bit after that at 2:30ish and beyond. So if you need help today, send me an email. We can schedule time to meet up. We'll be good. All right. Hope you have a great day. I'll see you tomorrow. Let's get a 1, 2, 3. Clap on me.